Hey class, just a quick recap here for today's geometry sketches. Today we did basically just a lot of vocab. We almost made a Pictionary version for a bunch of geometric vocab. Let's get started reviewing some of it. We started off talking about our lines, our points, and our planes and how to sort of identify, name, and describe them. Let's start off with point A. Point A, we were describing with just a little dot somewhere on the page, and it always has to be named with a letter. The point is just a location. It has no size. It has no shape. It is always named by a capital letter. You can see point A has capital A. We see points C and D have labels for them. We see points A, C, and T have labels for those 3 points as well. Always capital letters. The next two things we talked about, or the next thing we talked about, were lines. Lines had a couple different ways they could be talked about. We could have a line CD as described here. We could also reverse this and say it was line DC. We name lines with 2 points, points that are visible on the line. We also can name points with just a lowercase, cursive, script, italics sort of letter. In this case, we named this line G. An important reminder for you is that your lines should always have arrows on the ends, indicating that lines go on forever. A line is infinite in length, so it should be represented as such. Then we had our plane ACT. Planes were just flat surfaces. Any sort of piece of paper counts as a plane. It extends infinitely in all directions. So while my plane here has clear sort of borders, you have to imagine that the plane actually goes all the way to the left, all the way to the right, up and down. There is exactly one plane for any 3 points that are not on the same line. Notice that I can't draw a line through AC and have it connect to line T, connect to point T. These 3 points are not on the same line. They are not collinear or non-collinear. Those 3 points help us define the plane ACT. It could have been named another way. We could have named the plane TAC or CAT. Any order for those 3 points in the name would have been perfectly fine. We did a quick little review of line segments. Line segments are very similar to lines. They have 2 points that they're named for, in this case A, B. But unlike a line, which goes on forever in both directions, line segments have a clear end. They end at the 2 points that were given, A and B. They don't have arrows going on forever. A ray, in this case ray RT, starts at R and travels passing through T, going on forever. I like to think of rays like rays from the sun. A ray of sunshine starts at the sun, starts at R, and then starts traveling through space, leaving the sun. It might hit Earth here at T, or it might keep going past the Earth and continuing on forever. Here we've got opposite rays XY and XZ. Now you're going to have to sort of think about this one for a little bit. XY is a ray. We're starting at X, passing through Y, and XZ is a ray starting at X, passing through Z. We call these opposite rays because they are extending in opposite directions of each other. You're absolutely correct. Our opposite rays sort of look just like a line, because most lines are just opposite rays could be described as a set of opposite rays. CD could be a ray, or DC could be a ray. They're extending in opposite directions, making the line CD. We have the same thing here. Last here we've got plane P. Plane P is, again, just like plane ACT, it extends in all directions. Up, down, left, right, forever. It is a two-dimensional shape, like a piece of paper. But in this case, plane P is being described using, or is being named using a script, cursive, italics letter, in this case P. P is not a point on this plane. It's at least not labeled as a point on this plane. We could make a point P, say right here if we wanted, but it is not physically there unless we put a dot for our point. Then we had to talk discussions of collinear and coplanar. Collinear points were just points all on the same line. A, B, and C are all on this same line here, so they are collinear. Co-sharing, common together. Non-collinear points A, B, C are points that are not all on the same line. A, B, and C are now not all on the same line. B to C share a line, but A is not on the same line. We could draw a line through A and B, but then C would not be collinear with A or B, with AB as a line. Just as we can have collinear points and non-collinear points, we can have coplanar points. These are points that are all in the same plane. If you just poke your pencil along some paper and make a bunch of little polka dots, you get the same sort of thing. You get coplanar points on your paper. In this case, D, E, F, and G. Or I should have had D, F, G, H. Oh well, that's a typo. Notice that these 4 points aren't making one straight line. We could draw a straight line with 3 of them if we wanted, but if we're going to make a plane, we really need 3 points that are not in the same line. We need 3 points that are non-collinear. Non-coplanar points will have 1 point that is not lying in the plane for sure. B, C, and D could be forming this plane, and A is somewhere off of the plane, either above or below that plane, or maybe to the side, depending on how you view it. Now, to be clear, if we chose, say, A, B, and C to make a plane, that means D would not be on the same plane as A, B, and C. If we choose 3 points to make a plane here, the 4th one would not be on the same plane. Those were some of our more basic definitions. Then we did a couple more complex sketches. We'll take a look at those next. All right, continuing on. So we have 3 things we're going to sort of organize first, sort of like we did in class. We're going to focus on talking about these lines intersecting lines, lines intersecting lines, and lines parallel to another line. We're going to talk about those 3 first. When we're talking about line FG, realize that's talking about 2 specific points. So we're going to need to have a line that has 2 specific points on it labeled F and G. And our line's going to have to be intersecting, crossing line K at a point P. Let's see what that picture looks like. We have that. We see our point F, we see our point G, we see line K with a italics lowercase k indicating this line here. Those 2 lines, FG and line K, are meeting at our point P. We also have line EF as parallel to line GH. And we see E to F with our points labeled with capital letters, and GH with our points labeled with capital letters. We see the arrows on either side extending our lines to infinity. And I've also put these little tick marks, these little arrows inside or on the line as well. We remembered to mention this in a couple classes today. Just want to mention it again. These little arrows here are helping us indicate that these two lines are parallel. We use these if our picture is not a great picture, but also it's a good help to indicate, yes, these are actually truly parallel lines. Even if something looks like it's a parallel line, you shouldn't assume that the picture is parallel unless you see these symbols. The little arrow here, the little arrow here. Then we've got line C is perpendicular to line D at point R. We see D, we see C, we see the arrows pointing both directions, we see our point R. We also see this little square here at the corner here. This square at the corner here is a reminder that our two lines are perpendicular, that they're meeting at a right angle. Just as a quick side note, as a reminder, you might see this written instead as line, undo that a little bit, as line D is perpendicular using this sort of upside down T symbol to line C. The upside down T symbol that looks like two right angles is used to indicate that we've got two right angles here. We have a similar thing for E to F and G to H. We could say up here, we could say instead that EF, using our arrow notation, and GH are parallel. And how we indicate that things are parallel using symbols is a set of parallel lines, vertical parallel lines, just right between them. We'd read this statement as EF, let me add my laser pointer. We'd read this as line EF is parallel to line GH. The two vertical lines here are supposed to indicate the lines are parallel. All right, we talked about those three. Next thing in class, I asked you to think about taking a pencil, a line, and holding it, and how you can connect your line to a piece of paper, a plane. We sort of saw that there are three different ways we might have our pencil arranged with our plane. We could have our line touching our piece of paper at a single point. Your lines could intersect a plane at a single point, in this case point M. We could have our line touching our plane at infinitely many points because our line could be in the plane. In this case, ST is in the exact same plane as plane R. Imagine just sort of setting your pencil down on a piece of paper. You could say that your pencil is in the same plane as your sheet of paper. Your pencil S to T is in the same plane as your page of paper R. We could also have our plane and our line never intersecting each other. Easy way to have that is that our line has to be parallel to our plane. So just holding your pencil above the paper, but holding it flat above the paper. Just as a little sort of add-on to this, if we were to maybe draw a line in this plane, notice that this line here, notice that the line in our plane and the line above the plane never intersect. But they're also not parallel. What we'd call this sort of situation is we'd call it a skew line. We'd call these skew. S-K-E-W. Just a little extra tidbit. Last thing we really quickly talked over, just as a quick reminder, was how to name angles. We always basically name our angles by 3 points here, like BAT, but we could sometimes name an angle just with one letter, based on the assumption that there's no other angles made at this point. If I had, say, another line coming up from this, I could not just call this angle A. If I had another line just coming up from this, I could not just call this picture angle A, because I don't know where, if I'm describing this little part right here or this little part right here. And that's why we generally like to use 3 letters for our angles. We like to go B-A-T, or we could have gone angle T-A-B as well. Notice that the center letter in our spelling, B-A-T or T-A-B, is always the corner of our angle. It's the start of 2 separate rays, ray AB and ray AT. That's it for a recap today. Study, review this, and come prepped for tomorrow.